Welcome back to a new episode of Passion for Technology, the podcast from EPD Electronic. Great to have you with us.
Welcome to the Passion for Technology podcast. Digitization is conquering more and more market share in the field of drive technology. The growth rates of smart motors and motors controlled by frequency converters are well over 5% annually. What are the reasons for this success? What are the advantages of digital motor control? We'll be talking about this and more with our guest today. Ralf Kendall is retired professor for electrical drive systems and power electronics at Technical University of Munich. Hi, Ralf.
Hi.
Ralf, how would you describe briefly what constitutes digital motor control?
An electrical drive consists of three main components. One is the actor itself. That means the converter from electrical energy to mechanical energy and return. Then we have power electronics, and then we have control. The only component which was transformed into digital version is control. The actor was physics in all times. That was never digital and will not be digital in future. Power electronics was always digital, even some 50 years ago. So that will be digital in future, of course. And control, and this has really performed from being analog, now being digital. So a digital drive is just an electrical drive with digital control.
And Ralf, what would you say what the advantages are being offered by that turning digital now, the motor control part?
The main advantage is that the programming and the adaptation to the operation point or operation area is much easier. In analog control, and you wanted to change any parameters, you had to replace resistances or capacitances or whatever else. And you can imagine you don't do that in operation. In digital control, this is just a changing of numbers. This is very simple, if you do it correctly, of course, and can be done during operation. So it's much easier to adapt the operation of an electrical drive to the situation and to optimize the operation by a digital controller than it was possible by analog control.
So adaptation, modification is one advantage. I think another one lies with miniaturization. Why do digital drives need less space?
In my opinion, they don't need less space. And I tell you the three components. When you look to the actor, the size of the actor is just depending on the torque you produce. And when you don't change the torque, then you don't change the size and you also don't change the weight. And the actor is the most heavy part in the whole drive. This is not changeable if you don't change the torque. Of course, you can change the torque by going to higher speed. You see that in combustion engines as well. Today, cars have smaller motors than 30 years ago because they operate with higher speed. So the power is produced more by speed than by torque. So you need smaller motors. You can do that in electrical motors as well. But physically, when you need a certain torque, there is no choice. You cannot reduce anything. Now, regarding the power electronics, a reduction is possible by increasing the frequency. And we have new developments with new power semiconductor materials. People talk about wide bandgap materials. Even the former President Barack Obama knows that and has given a talk on that. So increasing the frequency means also a reduction in space, just because you have to use smaller portions of energy. When you go up with a frequency, you do not need to deal with so high amount of energies in each period of the frequency. So the whole system can get smaller, but it is a minor part. And regarding the electronics, of course, digital electronics is smaller than analog electronics. And the main reason is that it doesn't need so much energy. A digital controller needs less energy than analog electronics. And that means it can be designed smaller.
And Ralf, we've talked a lot about wide bandgap materials in our series in the podcast about, silicon carbide, gallium nitride. So very interesting that you bring it up here. What about noise? Is there any impact on the noise that drives produce when they're driven by digital motor control?
Yeah, there is an impact regarding noise. but not by the digitalization. It is more by the fact that we go to higher frequencies. Former times, the switching frequency of a drive inverter was around 10 kilohertz, maybe between 5 and 10, and our ears are sensitive enough to hear that. Now going to these wide bandgap semiconductor materials, we can go higher than 20 kilohertz. That means we don't hear it so much. It is a bit a pity for our dogs because they still hear it, but we don't. And if we go even higher, let's say 50 kilohertz and higher, then even the animals wouldn't hear it. So noise reduction is not a result of digital control. It is more a result of higher frequency in the power electronics.
Is the noise reduction happening to a degree that it has any impact on, let's say, electric cars or on factory buildings?
On my opinion, it makes the use of electric drives in electric cars possible because a driver, the standard customer, does not accept additional noise. Noise is a very critical issue. I worked many years for the Robert Bosch company, and Robert Bosch is operating audio laboratories to investigate in the noise of things like wipers, air condition, or whatever else. So noise is a very specific issue. So the best way, of course, is to have no additional noise at all. Of course, when you argue about that, there is a lot of noise when you operate a car, and even electric cars are not noiseless. But these strange additional noise like whistling or scratching or so, they shouldn't happen. And that is, I think, possible with the new drives going higher than 30, 40 kilohertz of switching frequency. In industry, the situation is a bit different. Let's say when electrical drives with control were introduced in the 1970s and 1980s, they just knew that it's noisy. And they took some provisions, maybe headphones or things like that for the people, but they wanted to make use of the advantages of controlled drives. So they accepted that, more or less. But a driver would not accept that. So today we are further on, and of course this improvement goes also to industry. So today drives can be much less noisy than in the past.
Ralf, could you elaborate a little more on the potential to save energy?
Yeah, the point is that the electrical drive itself has high efficiency. So we are not talking about 30% or 40%, we are talking about 95%. So by itself, there is not much loss. But the process which is operated by the drive sometimes has a lot of loss. As an example, when you operate a pump or a fan by an electrical drive, and then afterwards you shut down the fluid or the air by some throttle, then you lose energy, of course, not by the drive, but by the whole system. Now, with a digital control and even with analog control, you can operate the drive in the best point. So you don't need any throttles or valves to reduce the process. So you only spend the amount of energy you really need. And that means you can save energy. This is not by the physics of the drive itself, but by the possibility to adjust the operation of the drive. And that is a feature of drive control.
That's very interesting. Highly interesting. And can you think of applications that benefit most beyond, let's say, pumps or fans?
This is mostly in chemical industry. When I was a student, all these pumps and fans in chemical industry were operated at a stationary speed, constant speed, and then all the process was controlled by throttles and valves. And today you can see more and more that they implement their adjustable speed drives, and that saves a lot of energy. Some colleagues have calculated that the amount of energy to be saved can be around 25%. And that is, in fact, more than was necessary due to the Kyoto Protocol. The first meeting for climate change or climate saving was in Kyoto, and they had some goals, how much energy had to be saved. And that was even possible only by chemical industry. Of course, today we are much further. Today that would not be sufficient anymore. But definitely it's a lot of energy we can save just by adjusting the drive operation point to what is necessary.
With our podcast episode, you mentioned the benefits of digital motor control for modifiability, agility, adaptability. Can you tell us a little more about the flexibility and the impact of that type of convenience?
I think the main point is that digital control is able to store a lot of tables somewhere in the memory. That was not possible with analog control. In analog control, you had to find an operation point which I would say would be used mostly during the operation. And then you optimize the drive to that specific operation point. Of course, especially with cars, you are not operating the drive always in that same point. So in many situations, you have much less efficiency than you wanted to have. Now, in digital drive control, you can store tables and keep in memory the best operation points for all operation situations, and then just adjust the parameters of the control depending on speed, on torque, and whatever. And then you have always the best possible efficiency. That means you do not lose energy or you do not spoil energy, just spend the energy you need.
Is that information that gets pre-programmed into the devices, or is that something that gets adapted or is adapted as the, let's say, fan or another digital motor control operated device is being used?
At the moment, it is pre-programmed because I would say the engineers, especially the application engineers, are not yet used to do that. I see in the future that application engineers have more influence on that. At the moment, I would say it's the manufacturer storing all these tables and all these different operation points, and the customer relies more or less on the manufacturer that he finds the best operation point. But I think in future, engineers have to learn how to adjust themselves to make better use of it.
Ralf, among all the things that we've touched upon now, which of these advantages do you think is the most important driving force in the success of digital drive technology?
The adaptation of the operation point, the possibility to operate a drive always with the best possible efficiency. That means you do not spoil energy. And energy is topic number one for electrical drives, and I think for society as well.
Wow, thank you. I've learned a lot with just a few questions that you and I discussed over. Now, what I'd also love to learn more about, and this is something that we do in every episode of the Passion for Technology podcast, is I'd very much love to know, and our listeners would love to know too, I imagine, when and how you developed your individual, your personal passion for technology.
Oh, that's a good question. I recently made some PowerPoint presentation of my life because, as mentioned before, I'm retired, so I had a farewell party here and so. And I think my first contact with technology was my grandfather. He was a steamer of a locomotive. And I still know the type of locomotive he was working on. That, of course, was a steam engine, nothing electrical. And as an employee of German Railway, he also had a garden very close to the railway line. So I stood very often at the fence of that garden and watched the trains passing by. Maybe I was influenced by that situation. Later, I had, of course, a model railway, and I'm very sure if we would make more gifts of model railways instead of computers to our children, we also would get more engineers.
That's such a beautiful bridge. I mean, almost poetic. So thank you for sharing that. Well, thank you, Ralf. Thank you for the insights that you've shared with us today. And as always, everyone listening to this podcast, our audience, you can find more info in our show notes. Please feel free to subscribe to our podcast, Passion for Technology, on either Spotify, Apple Podcasts, or any of the other popular podcasting platforms. Ralf, thank you for joining us today.
You're welcome.